Hi friends, in this session we see part 2 of control system questions asked in Tneb exam, right? So the first question is, consider a feedback control system with the open loop transfer function given by g of s equal h of s equal to 1 plus 0.5 s divided by s into 1 plus s into 1 plus 0.2 s. What is the type of the system? How can we find the type? Type of the system is determined by number of poles lying at the origin. Here, how many poles are lying at the origin? I have one pole at s is equal to 0, because this makes, when you substitute s is equal to 0, total function will become infinity. That is nothing but a pole, right? Next, what is the other pole? I have one pole at s is equal to minus 1. When you substitute s is equal to minus 1 also, it will become, total function will become infinity. And I have another function at s is equal to minus 1 by 0.2, that is nothing but minus 5. But type is determined by number of poles lying at the origin. How many poles are lying at the origin? Only one pole is lying at the origin, which is nothing but s is equal to 0. So option B is the correct answer. Next one, gain crossover frequency is the frequency at which gain is unity, right? That is very important. Whereas phase crossover frequency is the frequency at which phase is minus 180 degree. So please remember that. So option A is the right answer. Next one, the expression for determining the peak overshoot of a second order system. So it is given by mp is equal to e power minus zeta pi divided by 1 minus root of 1 minus zeta squared. So option A is the right answer. It's a straightforward question. Next one, the characteristics equation of a feedback control system is s cube plus k squared plus ks plus 10 is equal to 0. Right? For the system to be critically stable, the value of k should be critically stable or marginally stable. See, they have given third order system. For third order system, we have shortcut, right? So first to find the product of coefficient of outer parameter and the product of coefficient of inner parameter. So what is the equation I have? So I give a shortcut. So what is the thing? Okay, yes, sorry. Right, here we are having s cube plus k squared plus 5s plus 10. First to find the product of coefficient of outer parameter, right? So these two, for it is applicable only for power of 3 equation only. So it is a shortcut. So this is inner, this is outer. So what is the product of coefficient? This coefficient is 1 into 10, 10. Inner is, this is k, this is 5, so 5k, right? Critically stable means we have to equate both, that is outer product should be equal to inner product. For stable system, inner product should be greater than outer product, right? IP must be greater than OP. This is nothing but stable. For unstable system, IP must be less than OP, that is inner product must be less than outer product of coefficient. So 5k is equal to 10. This implies k is equal to 2. Right? Simply you can find. So the answer is option B. You can use a Routh-Hurwitz criteria also and you can find. I did the same thing, but for third order only we have to follow this method. Right? Okay. So again I write, if inner product is equal to outer product coefficient, then it is critical stable or marginally stable. If inner product is greater than outer product, then it is stable. That is condition for stability. If OP is greater than inner product, then it is unstable system. Like that you can compare, right? For any question you can answer. Next one, system having a non-zero steady state error when the reference input is step input or labeled as, we know that when your input is step input, only type 0 system has non-zero steady state error. So option D is the right answer. For ramp, type 1 has non-zero steady state error. For parabolic, type 2 has non-zero steady state error. So for type 0, step. For type 1, ramp. For type 2, parabolic. For type 3, all are 0, right? Non-zero. Non-zero, there is no concept of non-zero for type 3. All all the inputs are having a steady state error of 0. Fine, next one is, given the damping ratio S is equal to 0.4 and undamped natural frequency omega n is equal to 5 radian per second of the second order system, the transfer function will be, we know that the second order system transfer function, in the new denominator we have s square plus 2 zeta omega ns plus omega n square, in the numerator omega n square. What is omega n? 5. So numerator should be having omega n square. It should be having 25. So option B is wrong. Numerator should be having 25. See here, you see omega n squared. So the last term should be 25. Okay, again all the three functions are having last term of 25. Okay, s squared. Second term is 2 zeta omega n. 2 into zeta is 0.4. 2 into 0.4, 0.8. 0.8 into 5, 4. So it will be 4s. So s squared plus 4s plus 25. So option A is the right answer. Right. Next one, in Bode plot, dash is used for frequency, is used frequency, and dash is used for amplitude and dash for phase. Right. We know that in Bode plot, x-axis varies with 1, 10, 100 or 1000 like that. So it is a log scale. Y-axis we measure a magnitude and phase in the normal scale, which is known as linear scale. So x-axis, that is frequency, is log scale. Magnitude and phase are linear scale. So option B is the right answer. Next one, feedback control systems are, yes, feedback control system will not at all, it is less sensitive to forward path parameter changes than to feedback parameter, right? That is the main advantage of feedback control, negative feedback system, right? They won't respond even though the parameters are, they won't change even though the parameters are changing, right? So they are less sensitive to parameter changes. That is very, very important advantage of feedback system. So option C is the right answer, especially negative feedback. Next one, s squared minus, sorry, s cube minus 4x squared plus s plus 6 is equal to 0. Fine. Okay. Then number of roots in the left of the s plane, right? So simply we go for Routh-Hurwitz criterion to find the number of roots. How can you find number of roots in the left top of the s plane? Left top of the s plane means we should see sign changes, right? If there is no change, all the roots are in left side. If there is a sign, we have to check. Let us see. Right, what is my equation? This is s cube minus k 4s squared plus s6. S cube minus 4s squared plus x plus 6 is equal to 0. This is unstable system because this equation has negative coefficient. Your equation has negative coefficient means surely it is unstable system. So some of the roots should be lying on the right of the s-plane, right side of the s-plane. Okay, let us see Routh-Hurwitz criteria. So s cube we get as 1. This is coefficient of 1. Then we have to go for odd power. So 1, 1. Next s squared. What is the coefficient? Minus 4, 6. Minus 4, 6. Then x power 1 means cross multiply and divide. Minus 4, that is minus 6 divided by minus 4, which is equal to plus 2.5. Then s power 0. S power 0 means 2.5 into 6 divided by 2.5. So again we get as 2.5 cross multiplication, 2.56 divided by 2.5, that is equal to 6, right? So the first row has 1 minus 4 plus 2.5, sorry, first column has 1, 4, 2.5, 6, right? So 1, 4, 1 minus 4, 2.5, 6. This is the first column. Since there is a sign change, surely some roots are lying on the right side of the s-plane. How can we find? Here it is going from minus to plus 2 minus, so one sign change. Here it is going from minus to plus, there is another change. So we have 2 sign change. That means 2 roots are in the right side of s-plane. what is the order of the system? It is maximum power is 3. So we have 3 roots. So 2 roots in right side, remaining 1 root in the left side of the S-plane. So from this, the answer is, how many roots are in the S-plane left side? Only 1 root in the left side. 2 roots are in the right side of the S-plane. Right? Okay. That's all about this session. If you are having any doubt, please ask me in comment section. I will clarify all your doubts. Thank you.